Hi guys, this is Miss Brown speaking. So this week we have been working with translating real world situations into algebraic equations. I need you to understand two things. I need you to understand that if it is algebraic, it will have a variable. I also need you to understand that if it is an equation, it should have an equal sign.
At this time, rotations. If you are in a rotation, that's Jedi and Knights, please head to the buses. Jedi and Knights, thank you for your help today. Good job staying apart. Teachers, thank you for being on duty. Mr. Clark, Mr. Green, Mr. Randy, Von Dolan, Courtney Brandt, so far all of you, Ms. Atkins. Thank you guys as I watch the video. Thanks so much for helping me. I might have missed somebody, and I apologize if I didn't call your name. Thanks, teachers, for helping me with buses.
Sorry guys about that announcement. So we are going to define a variable. Then we're going to translate each scenario into an algebraic equation, and later we're going to find the solution. When I say define a variable, you choose a letter, whatever letter. In this particular situation, I'm going to let my variable be equal to n. So I'm just going to say n equals, but you have to tell what n is equal to. Well, let me read the problem. It says 331 students went on a field trip. 6 buses were filled equally with students, and 7 students traveled in a car. How many students were in each bus? So the information we do not know here is the number of students in each bus. So that's what I'm going to let my variable be equal to. The number of students in a bus. So clearly, if we're letting the letter N be the number of students in a bus, then this bus would contain N students. And the next bus would contain N students. And the next bus would contain N students. And the next one, and the next one, and the next one. However, remember, 7 of the kids traveled in a car. So we have 6 buses carrying N students and 7 students in a car. Now, if I wrote that out, that would be N plus N plus N plus N plus N plus N plus 7. Okay? But we have talked about combining like terms. And when I combine all of these n's, notice there are 6 of those n's. When I combine them, that will give me 6 n's. But don't forget about the 7 kids in the car. And that is the total students that were on the trip. And remember, there were 331 total. So we would say equals 331. But we also have to find the solution, which means we need to solve the equation. Remember, when we are solving equations, our goal is to isolate the variable or get the variable by itself. And then remember step 1, we had to undo the constant. The constant is the number without a variable. It's just a number. In step 2, we had to undo multiplication or division of the coefficient. Okay, so we're going to isolate the variable. The variable is over here on the left-hand side. So I need to focus on the left-hand side. And the first thing I'm going to do is look for the constant. The constant is just a number without a variable. So my constant is positive 7. And the opposite of a positive 7 is a negative 7. But what I do to one side, I do to the other. So I'm going to rewrite that. I bring down the 6 in because I have not done anything to it. 7 minus 7 is 0. No need to write the 0. And 331 minus 7 is going to be 324. Alrighty. Now, we need to focus. We're trying to isolate the variable. Right now, the variable is here, and that variable is being multiplied by 6. So we have to undo that multiplication or reverse that multiplication, do the inverse with division. And we're going to divide by 6, but what we do to one side of our equation, we have to do to the other. 6 divided by 6 equals 1, so I have 1 n on this side, and 324 divided by 6 is equal to 54. So our solution is that there are 54 students in each bus.
Teachers, if you have any car riders that have a note to come up front or a text, you can send them, or if they're still waiting on a ride, car riders can go when the bell rings. I apologize that I forgot. They can just go on the bell, 20 after. Thank you, guys.
The next problem says Jill sold half of her comic books. Then she bought 16 more. She now has 36 comic books. With how many comic books did she begin? So we need to define a variable first. And the thing we don't know is the original amount of comic books. So I'm going to let C be equal to the original amount of comic books. Now let's think about what she did. Okay, she had her original amount, C, and then it said she sold half. So if she sold half, how many did she keep? Half, right? So we're going to take that original amount and we're going to divide that into 2 because half she kept, half she sold. So C divided by 2 represents how many she has that remains. But then she bought or purchased 16 more. So to the quantity that she has, we have to add 16 more. And it says now she has 36 comic books. So altogether she would have 36, right? And then we'd have to solve that. Kayla, you can go. So remember, first we're going to isolate the variable. And the variable is over here. So the first thing we need to do is look for the constant. And the constant is at positive 16. The opposite of positive 16 is negative 16. But what we do to one side of an equation, we have to do to the other. So I'm going to rewrite this. I still have C over 2, or C divided by 2. 16 minus 16 is 0, equals 36 minus 16 is 20. Okay. All right. So I'm still trying to isolate that variable. Variable's right there. But notice that right now the variable is being divided by 2. The opposite of dividing by 2 is multiplying by 2. Or the inverse of dividing by 2 is multiplying by 2. But remember, what you do to one side of an equation, you have to do to the other. Okay, so what's going to happen is this 2 over 1, these 2's are going to cancel out or simplify out, leaving you with just C. And 20 times 2 is 40. So that means she had 40 original comic books. Alrighty, let's go to another one. This one I like. Okay, so it says the sum of 3 consecutive numbers is 72. What is the smallest of these numbers? And guys, yes, I do need us to have a variable. And yes, I do need an equation. And I do need us to solve, okay? So this is not about just playing with numbers and getting the answer. It's actually not about just getting the answer. It's about, can you take the words and set up an equation? If we can't take the words and set up an algebraic equation and use the algebraic equation to get to the solution, then we're missing the whole point, okay? So let's talk about this whole thing of sum. Sum means that we are adding, okay? And then I need us to know that there are 3 numbers. Now let's talk about the word consecutive. Consecutive means one after another, or one following another. So let me give you an example of 3 consecutive numbers. So if I have a number 2, then the next number would be 3. The next number would be 4. Those are 3 consecutive numbers. All right. So what a lot of kids will do is they'll try to say like A equals the smallest, and they'll say like B equals the middle, and they'll be like C equals the largest, and they'll try to be like A plus B plus C equals 72. Well, let me tell you, you got a problem. The more variables you have, the more different variables. If they're all the same variable, that's not a problem. But the more different variables that you have, the harder that equation is going to be to solve. We cannot solve this setting up an equation like that. Even though that equation is technically correct, there's no way we can get the solution using that particular equation. So, that's not going to work for us. I'm still going to let A be the smallest, okay? So again, remember, A is equal to my smallest number. I want us to think about these 3 consecutive numbers that we've talked about over here. If 2 is my smallest number, which it is, how could I represent 3 in terms of 2? Again, how could I represent 3 in terms of 2? I could take 2 and add 1 to it, correct? All right. Well, how could I represent 4 in terms of 2? I could take 2 and add 2 to it, correct? You might be like, Miss Brown, what? I don't understand. Like, what's going on? Well, here's what's going on. So we're going to try to set up an equation using only one variable as opposed to using three variables. So I'm going to let my smallest number be equal to A. So the question is, how can I represent my middle number? And again, I don't want to use another variable. More variables just make things difficult. Do you notice what we did here to establish our middle and our largest numbers? Do you notice that? So if I take my smallest, if I take my smallest number, hold on guys, my pen's not working. If I take my smallest number and add 1 to it, that would be my middle number, correct? And let's talk about the largest number. If I take my smallest number and add 2 to it, that would be my largest number, correct? So if I am summing these together, I have to add them all together. So I add the smallest, which is A, correct? Plus the middle number, which we are representing with A plus 1, plus the largest number, which we are representing with A plus 2. And it says that the sum is 72. So all of that equals 72. But you might be like, well, Miss Brown, I have A plus 1 plus A plus 2. Like what am I supposed to do? Well, remember, we learned how to combine like terms. And like terms have the same variable raised to the same power. So hopefully we notice that A and this positive A and this positive A, that those are all like terms. So when we combine them, we have 3 A's and hopefully we also notice that this positive 1 and this positive 2 are like terms. So when we combine those, we have a positive 3. So we have 3A plus 3 equals 72. And then you just have to solve that equation. All right, and I'll let you solve that on your own. Going to the next one. It says 3 friends went shopping at a mall. Mary has $50 more than Becky. Wendy had $50 more than half the amount Becky had. Altogether, they had $600. How much did each person have? Let me make sure that I'm going to reread that, make sure I have all the information.
Ariana, please report to car rider. Ariana, please report to car rider.
So 3 friends went to the mall. Mary had $50 more than Becky. Wendy had $50 more than half the amount Becky had. They all had $600 together. So I need us to realize that we have 3 friends. We have Mary, we have Wendy, and we have Becky. And when they put all their money together, they're going to have $600. But again, here's the deal. A lot of times my kids will be like, M plus W plus B equals 600. Okay, this is no good. And here's why. Again, the more variables you have, the harder that's going to be to solve. So we need to try, if at all possible, just to use one variable. So let's think about this. Mary's quantity depends on Becky, right? And Wendy's quantity also depends on Becky. So everything's depending on Becky. So let's let our variable B be equal to Becky's amount of money. So it says Mary had $50 more than Becky. So that's telling me that Mary had 50. When it says $50 more than Becky, well, I'm going to take Becky's money and then which is B, or the amount of money that Becky has, and add 50 to it. That's how much money Mary has. Okay? And then looking at Wendy, Wendy has $50 more than half. 50 more than half the amount Becky has. So I have to take Becky's money and divide it in half. But she has 50 more than that. So that is how I would represent Wendy's money. Okay? And I'm actually going to rewrite this. This B divided by 2 is totally fine. But I think for what we're doing, it's going to be easier for me to think about it in the following manner. Half B. 1/2 times B. Remember, multiplying by half is the same thing as dividing by 2. Anyway, and then Becky, well, remember when we defined our variable, we said that was just equal to B. And that equals 600. So we have to put that all together. So we have to combine like terms. So notice we have B, 1/2 B, and another B. So B plus B plus 1/2. That's 2.5, right? And I'm going to use decimals to represent 2.5. So that's 2.5. 2.5 is the same thing as 2.5 as a decimal. I could also use an improper fraction, but what I don't want to use is a mixed number. So I have 2.5b. But then I also know that I have 50 and 50. So when I combine those together, I'm going to have positive 100. And that's going to be equal to 600. And then we just have to solve by subtracting 100 from both sides. And that would give me 2.5b. 100 minus 100 is 0, equals 500. But then I would have to divide both sides by 2.5. And that tells me that b is equal to 200. So I know that Becky had $200. Now, this says how much did each person have. So I have to go back and figure out how much Mary had. We know what B is, so we have to just kind of figure that out. And again, we know what B is here, so we have to figure out how much these people have, and I'll let you do that on your own. Thanks. Have a great day. Bye-bye.